In the last decade, the western U.S. has seen a dramatic increase in wildfires with catastrophic results, most notably in California, Oregon, and Colorado. But Utah has also suffered from our own fires and from sitting in the center of normal airflows that carry thick smoke to us. Now, new research from the University of Utah shows what that smoke is doing to the air that we breathe in the summer. We want to go in depth on this. So joining us live via Zoom is Kai Wilmot from the University of Utah, researcher there in the Department of Atmospheric Science and a PhD student. And Kai, thank you for joining us to answer some questions. This has become a real point of concern. And I wonder, in terms of the big picture, what are we seeing in Utah and how is it changing?
I guess the big picture for Utah is we're seeing trends towards increasingly poor air quality, both in August and September, which are statistically significant. So the expectation can be that that's probably going to continue happening into the future, and that finding's in line with other research in the field as well. So a bit of a bleak outlook.
And I understand that that saying that it's going into September, that is something new as well. The fire season's getting longer. Is it getting longer on this end? I mean, we've certainly had bad smoke here in July so far.
Yeah, I mean, there's definitely literature pointing towards just a widening of the fire season, I believe on both ends. I would consider this smoke to definitely be a little premature for the fire season in Salt Lake City, just based on what we've been looking at in our recent research. But I guess given drought conditions throughout the West and recent heat waves, it's not totally a shock either.
And one thing that's different too, I think, is those of us who live on the Wasatch Front, we're used to the winter inversions with the particulate pollution, but this is more pervasive. This isn't about being stuck in a valley that's trapping things in. People are getting pollution up and down the state.
Yeah, absolutely. I mean, one of the biggest findings, I think, of our paper is just that this is such a regional issue. It's not just affecting Utah either. It's really a lot of the West. So, yeah, whether you're in the valley or not, you're probably going to experience it this summer.
Now, I know that you're studying atmospheric science, and so you're not necessarily the medical expert, but can you tell us anything about what's different about the particulate pollution that we get in smoke, what we're breathing in from these summer fires compared to what we get in that winter smog?
I mean, it has a different chemical composition. This definitely isn't my particular expertise, but I mean, we're going to see a lot of PM 2.5 associated with fires, which we also see in the inversion events, and that has a pretty clear negative respiratory impact. That's really all I have to say on that, I suppose.
Yeah, no, that completely makes sense. And going back to your forte with the atmospheric science, where is Utah placed in all of this? I always have, I just watch our meteorologists here every day showing the satellite views of where the storms blow. And I just kind of get the sense that severe fires located closer to the West Coast, we're right in the middle of the path of where that air is going. Do we get more of it than other places?
Based on our recent research, it seems like the Pacific Northwest is really getting the brunt of this issue. But given our position generally downwind of California, we are picking up smoke from the large fires that direction, and that it's going to continue to be that way moving forward. The other interesting thing about Utah is just it seems to kind of sit on this gradient between the Pacific Northwest as you move down towards Arizona, where we see stronger impacts in the Pacific Northwest, a little bit reduced as we get down towards Arizona, and we're just somewhere in the middle.
Yeah, and when we look at this happening, you mentioned it's a concerning trend that you see going into the future. Is it clear now this is connected to climate change?
Yeah, I mean, there's certainly a wealth of literature suggesting that climate is going to lead to larger and more intense wildfires, and that's what we're seeing. And I mean, it makes sense from the perspective of if we have drier fuels due to enhanced drought from climate change, we can expect to have larger, more frequent, and more intense wildfires. That's going to generate more smoke, and here we are.
Talk about what comes next. What plans do you make to maybe improve models for how we can predict what's going to happen, where the smoke is going to blow?
At this point in time, I'm starting in on some research where really the objective is to identify where does smoke that's hitting Salt Lake tend to originate? Are there specific areas that seem to be particularly relevant to this question? And that might help us point us in the right direction for kind of addressing bigger issues of maybe how do we stem the flow of smoke from these primary source regions.
All right, Kai Wilmot, a PhD student from the Atmospheric Science Department at the University of Utah. So glad that you had some time to spend with us today. Thanks, Kai.
Yeah, absolutely. Have a good one.